On this one, we're finding the local extrema of this function. Extrema meaning the max or min, so local max and local min of this function. We know that if we have a local max or a local min, the derivative is going to be 0, or the derivative is going to be undefined at some point. So I need to find the derivative either way. So we need to find the derivative of this right here. So the derivative of this is going to be this multiplied by the derivative of x plus 2, but the derivative of x plus 2 is just 1, so that's fine. And then plus x plus 2 multiplied by the derivative of this. Now, the derivative of this is going to be 2/3 x to the negative 1/3, or in other words, 2 over 3x to the 1/3. And I'm just going to leave it as 1/3 for right now. So this is going to be multiplied by 2 over 3x to the 1/3. Now, I need to solve this, set this equal to 0, and I'm not going to be able to know what's going to work here yet, so I need to kind of manipulate it a little bit. So I'm going to go x to the 2/3, and then plus, I'm going to distribute this in, so I'm going to get 2x over 3x to the 1/3. And then I'm going to go plus 4 over 3x to the 1/3. Now, I need a common denominator here. This has 3x to the 1/3. This has 3x to the 1/3. So if I want this to have a common denominator, I need to multiply the top and bottom by 3x to the 1/3. Which then means, well, 3 times this is just going to be 3. And this is going to be x to the 1/3 times x to the 2/3. And remember, if you're taking anything and you're multiplying anything with the same base but have exponents, you actually just add the exponents. So that's what I'm going to do. I'm going to add 1/3 to 2/3, which ends up being 3/3, which is just x, all over 3x to the 1/3. Now, if I replace this with this, and I get a common denominator and put them all together, I'm going to end up getting 3x plus 2x plus 4 all over 3x to the 1/3. All right. Now, at this point, I'm going to combine like terms. So I'm going to get 5x plus 4 all over 3, and instead of x to the 1/3, I'm now actually just going to call this the cube root of x. All right, so now we need to know where this is 0. My zeros, as you remember, are going to be anywhere where the top is 0. So in other words, 5x plus 4, anytime that's 0 is going to be a point of interest. So I'm going to subtract 4, divide by 5, so x is going to be negative 4/5. That is going to be, and if you remember in class, it's either going to be where this is 0, or where it's undefined, or where the endpoints are. But there is no endpoints because we're talking about a full function here. So we don't have to deal with endpoints. But we do need to deal with the zeros, and we do need to deal with when it's undefined. It's going to be undefined when 3 cube roots of x is going to be 0. So divide by 3, you get the cube root of x equals 0, and then cube both sides, you get x equals 0. So there are my points of interest. So I am going to erase all of this, and I'm going to get a number line. I'm going to put these two numbers on my number line, negative 4/5 and 0. Remember, in order for there to be a max or a min, the derivative has to change sign. So I need to do a sign chart of my derivative. Now remember, this is my derivative sign chart, not my actual function sign chart. So my derivative sign chart, so I need to plug something that is less than negative 4/5 into my derivative. So I'm going to plug negative 1, because negative 1 is going to be over here, into my derivative. So that's going to be 5 times negative 1, which is negative 5, plus 4, which is negative 1, all over negative 1 cubed, which is negative, and negative 3, so that's going to be positive 1/3. So I know it's going to be positive here. Now, in order to plug something in between here and here, there's a really tiny space. I'm going to choose, let's do this better. So we found out that if we plug y prime into negative 1 into y prime, I end up getting 1/3, which was positive. Then I'm going to plug y prime. I'm going to plug in negative 0.1 into it because that's in between here. And I plug that into my calculator, and I end up getting negative 2.5. So that's negative 2.5. I'm going to plug in 1 into my derivative. If I plug 1 into my derivative, I get 5 plus 4, which is 9, all over 3. So 9 over 3, or in other words 3, that's going to be positive. So it goes positive, then negative, then positive. All right. Now if you look here it goes from positive to negative, and here it goes from negative to positive, which means there's going to be a max or min here, and there's going to be a max or min here. And you got to think about it. These are the slopes. So my original function is going to have a positive slope and then go to a negative slope here. And then it's going to be a negative slope going to a positive slope here. So right here, I'm going to have a max. I don't know where the max is going to be. I know where it's at, where it's going to happen, but I don't know what it is. So what I need to do is I need to plug this into my original equation. So if I plug this back into my original equation, I will have a max at, if I plug it in my, let's get rid of some of this right here. So if I plug negative 4/5 into my y, I'm going to get negative 4/5 to the 2/3 multiplied by negative 4/5 plus 2. Now, I'm just going to not worry about getting exact values. I'm actually going to get a decimal approximation. So I'm just going to plug that into my calculator. So I get negative 4/5. Let's see, we need a parenthesis. Negative 4/5 to the 2/3. Then I'm going to multiply that by negative 4/5 plus 2. I think that's what I got. Okay, and if I hit enter, I end up getting 1.034. So we're going to end up getting 1.034. And then while we're here, I might as well plug in 0 into here to see what my min is, where my min is going to be. And if I plug that in, I get a 0 here, and then 0 times anything is just 0, so that's just 0. So my answer is, I will have a local max of 1.034 at x equals negative 4/3. 4/5. And then I will have a local min of 0 at x equals 0.